as we go into systems of equations now in topic 3.6. Just a little background review. Here we see three graphs and the equation here. Now, this would be one equation, but suppose you had another equation, and when you did the graph of the second equation, the line looked like this. And let's say another equation, the line would look like this. And in a third scenario, the line would look like this. This is the second line. And then we're asked, well, what's going on here? Well, here, because of the nature of the graphs, we see there is a point of intersection. So this is going to be an ordered pair that would be a solution of both equations, their point of intersection. And we say the equations are independent, but since there is one set of solutions, we say they are consistent. Some vocabulary review from our video. And then here, the lines are never going to intersect because they are parallel lines. So again, these equations would be different. So they are independent equations. And they are inconsistent because they never intersect. And then in this third scenario, since the lines are actually the same, the equations are dependent and they are consistent because there's an infinite number of points of intersection. So these are scenarios as background of what we're doing in topic 3.6. Now what we're asking you to do is determine the solution of equations represented by the lines in the graph. Check your solution by using substitution for both equations. Now, in our flipped classroom video, we gave you some background for this. And I'll get you started by saying, let's solve this equation for the letter y. Well, if I move the y over to this side, it becomes positive. And then I have x still on that side. I'm going to transpose the 9 to this side, and it becomes a negative 9. So we've solved this equation for y. Now let's solve this equation for y. Again, I'm going to transpose the y to this side, becomes positive. And we get 2x, and then I'm going to transpose this 13 to the other side. So we now have two equations that have been solved for y, and we're asked to use substitution. Well, this is a value for y, and this is a value for y. In a sense, we have y equals y. This y equals this y, and now we're going to substitute. X minus 9 equals 2x minus 13, and that's where we are. So we'd like you now to take time to solve this equation to tell me what x equals. All right, did you get something like this? Going to take the x over to this side where it becomes a negative x, and this just becomes then a positive x. Transpose the negative 13 to this side where it becomes a positive 13. Take 9 away, and you get x equals 4. So you have one of your ordered pairs now, a 4. Now, we can go to this equation up here, and we're going to put there a 4. So 4 minus 9, just substituting, equals y. So this is going to be a negative 5. So through substitution, now this is one way of substituting. We showed you another way earlier, and you may use that other method as well. Now in example 2, we're asked to solve the following systems of equations by graphing. And in order to graph them, they're asking us to write them in slope-intercept. Y equals mx plus b, which we've been working on. So we'd like you now to take this equation and this equation, solve for the letter y, and you're going to put them in these boxes, and we'll give you time. So we're transposing the negative 7x to the other side, where it becomes positive. And we did the same thing with the negative 6x, transpose it, and on this side it becomes positive. And now what do we do to find out what y is? Well, we divide each term by the numerical coefficient of y, and we get y equals x minus 1. Here we're going to divide each term in the equation by 6. And look, we get y equals x minus 1. Oh, so over here, you see, we don't put a 1 there. This is x, and then in parentheses we can put a minus 1. These equations are the same. So even though they looked different when we first looked at them, putting them in a form we can recognize the slope and the y-intercept, we see they're the same. So what is the solution? Well, the equations are dependent. They're the same equation, just hidden. And since there's an infinite number of solutions, they are also consistent. Okay. Now let's take a moment to graph it. And again, our equation was y equals x minus 1. So we can use that technique of plotting the y-intercept and then the slope, which is 1 over 1, and it's positive. Let's see what you come up with. All right, so our y-intercept is 1, and we're going to go over 1, up 1, over 1, up 1. I'm just getting a number of points here. Then I take my line tool, and you can sketch it however, and it ends up looking something like so. Okay, again, something easy and a little review. Now, for example 3, we're asked again to solve by graphing. Here are the equations in the standard form. They want you to solve for the letter y, put it in slope-intercept form, and that'll be our next little task. So we'll pause. Let's see what you get. So we transpose the 2x on this side becomes a negative 2x. Divide everything by 2 and we get y equals a negative x minus 8. And here we're going to transpose now a negative 7x. On this side it'll become a positive 7x. And again, we're going to divide everything by 7. And we get y equals x minus 2. Now, let's just look at these and see what's going on here. First of all, the slope here is a -1. Here the slope is a +1. And the y-intercepts are different. And one other thing as a little review, if you multiply the slopes together, what do you get? A -1 times a +1 is a -1. So these lines are what? They are perpendicular because their slope, one is the negative reciprocal of the other. Again, a little review. So now what they're going to ask you is to graph this. So on the next page, and I'll leave the work there so that can guide you. And again, if you had the little whiteboards, I'd be asking you to show this. I'm not sure how we could have you show me this, but eventually I'll be checking notebooks. So let's see what you get. So something like this, and then you are to pick out the point of intersection. So we'll give you a moment for that, see what you can pick out. Well, our x-coordinate looks like a -3, and our y-coordinate a -5. So if you were to put these values, they are a solution for both equations, and I've done that, and I checked it, and this is what it looks like. Again, any questions? Lots of review items here. Now, for number 4, they're giving us the graph, and here you are asked to pick out the ordered pair. So take a moment and see what you come up with. Now, as you look at it, you probably picked out a 4, comma, -5. So there's the 4 and the -5. Yes, that looks good. But now you want to see if these values make each of these true. So let's do some substitution. Here we're saying x is 4 minus a -5. Does that give you 9? Well, yes, that checks. And this one is 2 times 4 minus a -5. Does that give you 13? Well, this is 8 plus 5 is 13. Yes, that checks. Now, before we leave this, because again, we're going to get ready for a test here sometime in the future, let's use that x and y intercept to find x and y intercept t-chart to double check this graph. So if we put a 0 there, you put a 0 there, take a moment and see what you can fit in. Well, for this first equation, if x is 0, y is going to be a -9. If this is 0, negative y equals a +9, just reverse the signs. Now, if y is 0, this y, so -0 is 0, x equals 9. These are your intercepts, 0, comma b, and a, comma 0. Again, a little review while we're on this slide. And where is it going? Well, there's a 9 there, and there's a 9 there. That worked out very well. All right, let's do the other equation. We're making an X and Y intercept T-chart. Very useful tool in graphing. Now, this is the second equation. If X is 0 here, 2 times 0 is 0. This is going to be Y is a negative 13. So that's off our graph. We can't check that one. But now if Y is 0, we get 2x equals 13. So this is going to be 13 halves, which is 6.5. So if we go here, yeah, this is right there. Normally that would be hard to plot, but since we knew what the point was, it worked out. All right, so this is a rather short lesson and hopefully helpful. You'll have your practice and your certify. And of course, ask any questions.